चैप्टर वाइज नीट का क्वेश्चन एनालिसिस करेंगे। क्वेश्चन पूछा है फ्रॉम इलेक्ट्रोमैग्नेटिक वेव। इट इज नोन टू इन इलेक्ट्रोमैग्नेटिक वेव if x-axis is the direction of propagation, the electric field and magnetic field are always perpendicular to each other, means with the direction of propagation also, and always the direction of propagation also called as pointing vector, always in the direction of E cross B. C cap is always in the direction of E cross B. And what question asked, electromagnetic the wave is propagating along x-axis, find appropriate the direction of electric field and the magnetic field, and options are given. Now just go for E cap cross B cap, इसको ले ले E, इसको ले ले B, and go for cross product. If answer is I cap, then that option is correct. Just solve for it for the first option, you will find answer is I cap, so answer option A is correct. One more question asked upon semiconductor. Question asking what? There are two p-type material, another is n-type material. Got equal concentration of electron or holes. If an electric field is applied, same electric field, then in which case current will be more? Current will be more in p-type or in n-type, or less or equal, whatever the question asking. It is known to you, drift velocity of electron is large with respect to the drift velocity of holes, approximately 200 times. For same electric field, obviously drift velocity in n-type will be larger. p-type maximum hole got concentration, so in this case current is less. So current in n-type is more than current in p-type. One more question asked upon nucleus, chapter nucleus. A nucleus of mass number 240 break into two parts of mass number 120 each. And the binding energy of the parental nucleus is 7.6 megaelectron volt per nucleons, and binding energy for the products is 8.5 megaelectron per nucleus. The question asking what is the increase in binding energy? Increase means final energy minus initial energy. So final energy is how much? 240 total mass number into 8.5 each per nucleus. And for the parental it is 7.6, 240 minus 7.6. Just go for a difference, you can get increase in binding energy of system. Another question based on the radioactivity. Question is given that a particular the radioactive substance got half-life 100 hours. Find the fraction of original activity after 150 hours. Activity proportional to n, and n written as n naught into half to the power T by T half. T by T half. So in this case, half to the power 150 by 100, 3 by 2. So n naught by 2 root 2. As n becomes n naught by 2 root 2, activity also changes accordingly. So A by n naught is equal to 1 by 2 root 2. So answer is 1 by 2 root 2. Another question is asked upon photoelectric effect. In particular, photoelectric metal got negligible work function according to question. Incident wavelength lambda. Find associated de Broglie wavelength associated with the fastest emitted electron. So So SC by lambda is incident energy. There is no work function. So kinetic energy of fastest electron can be written as K, let me say. Energy can be written as P square by 2m because electron is a particle. For particle you can write kinetic energy P square by 2m. M is the mass of electron. If you remember, momentum of a particle can be written as h by de Broglie wavelength. So it can be written as s square by lambda d square by 2m. So from this part you can get lambda d. So lambda d can be written as square s square by 2m lambda by sc, and you can solve for lambda d. One more question asked upon particle theory of light. Any light emits photons. That particle nature or that particle is called as photons. The question asking, and each photon got energy how much? Sc by lambda. Each photon got energy Sc by lambda. And what the question asking? A particular source of light emitting wave of 600 nanometer. Power is given as 3.3 in 10 to the power minus 3. H is given. Question asking number of photons per second emitted by that source. Power is nothing but energy radiated per unit time. By Sc by lambda is nothing but number of photons emitted per unit time. Just put the value of P, lambda and H here to get the number of photons per second. Another question asked on optics. Two coaxial lenses, one of focal length 20 centimeter and the focal length minus 5 centimeter, placed at separation d. Find value of d for which, if the incident beam is parallel to axis, the final emergent beam also parallel to axis. From the ray diagram we can solve this question. For a convex lens, if the ray is parallel to axis, they will focus at the focus. But in case of diverging lens, if the ray are converging ray are incident which supposed to pass through focus, they becomes parallel after refraction. So that unless you can say, if they got a common focus somewhat here, and the ray is supposed to meet at this point. This focus is common focus, then the ray becomes parallel. And this particular distance is 5, and this total distance is 20. So d is nothing but 20 minus 5 as 15 centimeter. A ray of light is incident normally to a face of a prism as shown in the figure. If mu, the refractive index is √3, find the emergent angle. Find the emergent angle. The ray, as the ray is incident perpendicular to surface, the ray moves undeviated, moves straight. So at this point, as this angle is 30, this angle will be 60, and this angle is 30 degree. So ray emerges somewhat like this. This angle is called as emergent angle. From Snell's law, you can write to √3 sin 30 equal to sin E. Here got reflected in this one, and solve for E. E is 60 degree. This question is based on alternating current. In alternating current, a capacitor is connected to AC source V0 sin omega t. The question asking find the displacement current between the plates of the capacitor. The changing electric field behaves as a displacement current. It is known to you, the displacement current written as epsilon into d phi E by dt, the rate of change of flux into epsilon is nothing but displacement current. And according to Kirchhoff's law, the displacement current and the drift current I should be same, means I is equal to ID. So I have to find this current at least, because that drift current will be same as the displacement current. And it's known to be in case of capacitor, current leads voltage by pi by 2. So right, current can written as V naught by X. X is omega C, 1 by omega C. 1 by omega C, sir. Into sine omega t plus pi by 2. Because in case of the capacitor, current leads voltage, voltage got phase 0. So the current should get a phase pi by 2. This is the answer. Another question from alternating current itself. Series Lcr circuit is connected to AC source. Potential drop across the inductor is 40, across capacitor is 10, across resistor is 40. And the peak current is given as 10 root 2 ampere. Find impedance of the circuit, means Z. It is known to you. At this voltage, all are in different phase. If this current got phase 0, this 40 volt got phase pi by 2, 10 volt get phase minus pi by 2, and 40 volt in phase. This part is inductor, this part is resistor, this part is capacitor. So resultant voltage is जैसे जैसे कि वेक्टर ऑफ यूज करते कर लीजिए तो कितना आ रहा है 50 वोल्ट. सो आरएमएस वोल्टेज इज 50 वोल्ट एंड आरएमएस करंट is 10 ampere. Z can written as V by I, both RMS 50 by 10. In a series Lcr circuit, L, C and R is given. It is connected to AC source of 230 volt RMS voltage with variable omega. It is known to you, current versus omega curve will be somewhat like this. At a particular omega, the current is maximum, that is called as the resonating omega. And what question asking? Power consumed in circuit at the resonating omega is omega naught, and half power consumed, let omega 1 and omega 2. Find omega 1 and omega 2. When power consumed is half of the resonating frequency. So power consumed half means what? Current should be I naught by root 2. At resonance, Z is equal to R, because R, XL and XC. When this XC and XL are equal, that particular point is called as the resonating frequency, at which Z is equal to R. If current is I naught by root 2, then Z becomes root 2 R, yes or no? If Z will be root 2 times, current will be 1 by root 2 times. So for Z to be root 2 R and Z means X should be same, such that the resultant Z can be root 2 R. So X is equal to R. So X is what? Omega L minus 1 by omega C equal to R. And in second case, 1 by omega C minus omega is equal to R. So we'll get two cases for the omegas, means omega 1 and omega 2, current is the 1 by root 2 times that of resonating frequency, at resonating frequency. And solve these two equations to solve for omega, because R, omega, L, all these parts are given. You have to only find omega in first and second case and try to solve it. One more question asked on from electromagnetic induction. Two coils, two circular loops, the conducting loops of radius R1 and R2. This R1 is very, very large than R2. They placed concentrically. Find mutual inductance of this arrangement. Mutual inductance always written in flux in secondary loop by current in primary loop. So it is better to choose the smaller one as the secondary loop, assuming for the current in primary loop field is uniform in that particular region. You can choose first this R2 part as primary and outer part as secondary, you will get the same answer, but it's a very lengthy process to solve. So it is better to choose the smaller one as but second loop to find flux, which is easier. So for current in primary loop, let me say I, magnetic field at the center, mu naught I by 2R1. Assuming field is uniform in this region because this R2 is very, very less. So into area pi R2 square. This part is nothing but the mutual inductance, sorry, flux by current in primary loop is I. So this I part will be cancelled and you can solve for M. So in this we can calculate mutual inductance of arrangement.